The last video introduced the graphs of the sine and the cosine functions. The results are as shown in the screen. There's an S-shaped curve oscillating between 1 and -1 in the y-axis, and over a period of 360 degrees the curve repeats itself. The sine and the cosine graphs are both sine waves. If you take the sine x function and look at its graph here in solid black, if you shift it 90 degrees to the left, it is the red dotted cosine graph. So complementary angles add up to 90 degrees. Cosine is the complement of the sine. So the cosine function is the sine function but shifted 90 degrees to the left. You need to know the graphs over the interval 0 to 360 degrees, one cycle. You need to have 4 intervals of 90 degrees each and memorise key parts of the curves. Here they are here. For the graph of y equals sine x, the graph peaks at 90 degrees 1, x coordinate 90 degrees, y coordinate 1. The value of the function, that's the output of the function here, is 1. The input is 90 degrees. The minimum is at 270 degrees -1. So the maximum value is 1, the minimum value is -1, and the period 360 degrees. These 5 key positions you should know because they will be manipulated when we carry out graph transformations. In transforming the graphs, changing them, we will affect the x here, that's the input, or we will affect all of sine x, everything that's here, which is the y coordinate. If sine x is affected, certain changes occur. If just x is changed, different changes occur. Same on the cosine curve here. These 5 positions, they are simply these 5 from the sine wave shifted 90 degrees to the left. We're going to use a graphing package to examine the changes. So this is the graph of y equals sine x. The x happens to be bracketed here. It doesn't need to be bracketed, but it's very handy because with the x in the brackets, which is the input to the function, any changes to x we can describe as changes inside the bracket. So there will be changes to x and they are inside the brackets, it's the input to the function. Or we'll make changes to all of sine x, the whole of the right hand side. So we can distinguish between what's in the brackets and what's outside the brackets as being the difference between affecting the input or the output of the function. So when you dealt with functions in the introduction, we described a function as having an input, in this case x, the angle, and an output, in this case all of sine x here. So if, for example, you inputted the angle 30 degrees, its output would be sine 30 degrees. So in graphing the function, the coordinates are x, the input, as the x coordinate, and sine x, the output, as the y coordinate. So we write the equation to describe this as y equals sine x. That is, for the input x, the output is sine x, which is the y coordinate. So for example, if we have the graph of y equals 2 sine x, which means sine x multiplied by 2, we have just doubled the output because we're doubling all of sine x, and sine x is the output. So when we double the output, the point that was 90 degrees 1 becomes 90 degrees 2 because the y coordinate get doubled, the output of the function. The input 90 degrees didn't change. So here we changed the output, the y coordinate, but we didn't change the x coordinate in any way. So when it's y equals 2 sine x, this is doubling the y coordinate. There's 3 sine x, it's now 90 degrees 3. If we do this, which is in the brackets here, doubling x, that means our input gets doubled. Now that means when we put a value in for x, an angle, that angle then gets doubled. And that means we can put in half of what we used to. So what used to happen at 90 degrees can now happen at 45, because if we put in 45, it gets doubled up to 90. So we can put in half our previous x coordinate. So our peak was at 90 degrees 1 before. It now happens at 45 degrees 1 because we can half our x coordinates. So opposite effect from what you might at first expect. 2x does not double the x coordinates, it halves them. Now, in the same way, if we were to go to 3x, that divides the x coordinates by 3. We could put in a third of what we used to as an input. So 90 degrees 1 became 30 degrees 1. The period had been originally 360 degrees. We now divide that by 3, and this position is 120 degrees 0. So the period is 120 degrees. We divide the period by 3, it completes 3 cycles and 360 degrees. So that's 3x means 3 cycles and 360 degrees. All the x coordinates got divided by 3. So that's the difference in these changes. It's a question of did we change the x coordinate, that is what's inside the brackets, or did we change the y coordinate, that's the whole of sine x here. Now if we go back to the first change, there's y equals 2 sine x. The key positions are at 90 degrees the peak became a value of 2. That's a maximum value of this function. Y equals 2 sine x is now 2, and it happens at 90 degrees. The minimum, which previously was 270 degrees negative 1, becomes 270 degrees negative 2. The y coordinate get doubled from negative 1 to negative 2, but the x coordinate didn't change. Also, the other 3 key positions is where it meets the x-axis, that's with the y coordinate 0. It's still here at 0, 0, 180, 0, 360, 0. The reason is the y coordinate is 0. If you double it, it's still 0. So these positions don't change. It's as if you fixed the curve with a nail at these 3 key positions so they don't move, and the graph was made out of elastic, and you stretch the elastic and pull the curve up to the position 92, 270, negative 2. So that's called a y stretch. It's in the y direction, and it's as if the graph's elastic and fixed down with nails at positions 0 degrees, 180 degrees, and 360 degrees. So it's a y stretch. Now, when we had this change, which was affecting the x coordinate, halving the x coordinates, it's again, this is called an x stretch because you could pull it like elastic, although in most cases you're more squashing it in. So this is an x stretch, but it's squashed in from left and right of the y-axis. So you can't see it, but often to the negative angles there, it's been squashed in as well. So it's squashed in left and right. So it could be stretched out or squashed in the x direction, and mostly it'll be squashed in. The period changes here. Because of this 2, the period is halved to 180 degrees. So a y stretch, an x stretch. Now these 2 changes are the main changes you need to get to know. They will be combined. So for example, that's 3 sine x. Notice the y coordinate's tripled. Now the x coordinates are affected. The period has halved. it's halved all the x coordinates. So the change here was, for what's happening in the brackets, you half the x coordinates. So 90 degrees became 45 degrees here. And for what's outside the brackets, this 3, that tripled the y coordinates. So these are the main changes. Here they are summarised. Y equals k sine x. That was a vertical stretch, the y stretch, by k units. It multiplied the y coordinate by k units. And this change in the brackets here, that was an x stretch. You divided the x coordinates by k in this case. So the period is 360 degrees divided by that k. And the same changes will occur for the cosine curve. This is the effect in the coordinates. When it's y equals k sine x, that affected the y coordinates, they were multiplied by k. When it's y equals sine k of x, it's in the brackets, that affected only the x coordinate. It was in fact divided by k. So here, y coordinates changed, x coordinate remains the same. Here, the x coordinate is changed, but the y coordinate stays the same. Putting numbers in to make it a wee bit more clear. The peak in the sine curve was at 90 degrees 1. So if you're dealing with y equals 10 sine x, that's 10 times the y coordinate. This 90 degrees 1 shifts to become 90 degrees 10. We're multiplying the y coordinate by 10. Here, when it's y equals sine 10x, it's the x coordinate, but in fact divided by 10. So 91 became 91, dividing the x coordinate by 10. So sitting over all the function, that's a y coordinate affected, because sine x is the output, the y coordinate gets changed here, being multiplied by 10. Here it's the input that's being affected. We divide the input by 10, and that changes the x coordinate. Now the same happens if you're dealing with the cosine rule, the cosine function. So here, looking at the cosine function, it just looks different in that 0 to 360 degrees interval. Peaks at 0, 1, equally it could be 361, and it goes to its minimum at 118, negative 1. So there's the two graphs compared. Shift the graph in red, 90 degrees to the left, you've got the cosine. So the changes are going to be exactly the same, it's just where they happen. That is, it's the where they happen on the angle, that is changed to between the sine and the cosine. So here's some of the manipulations. There's 2 cos x, y coordinates doubled, 0, 1 became 0, 2, 180, negative 1 became 180, negative 2. But on the x-axis, they're fixed here because the y coordinate was 0, and when you doubled 0, you got 0. So 90, 0 stayed 90, 0. 270, 0 stayed as 270, 0. It's as if they're fixed there by nails, and you stretched the elastic curve. So that's the y stretch. There's y equals 3 cos x. The y coordinates are multiplied by 3. So that was the y stretch. And there's y equals cos 2x. This is an x stretch where it gets squashed in this case. The period is half to 180 degrees. It does 2 cycles. That's starting up at the top here, going down, stopping at 180. That's the period. It then repeats itself till it reaches 360. So that's 2 cycles and 360. The period gets halved. The x coordinates get halved. Now, what used to happen at 180, negative 1, is now happening at 90, negative 1. The peak here is still 0, 1, because if you half the x coordinate 0, it doesn't change. Same at 180 here. 1, it's just like 361. You half the x coordinate, it became 181. Now, again, you can combine these changes. So let's say I made that 3 cos x, that's triple the y coordinates. And then I've halved the period. So that's 3 cos 2x. Y equals 3 cos 2x is the y coordinate get tripled because you're tripling all of cos 2x. And inside the brackets, when you've got this 2x, you're actually halving the x coordinates. So these are all combinations of changes that you need to get to know. So what happened here with the y equals sine x, it's the same business for y equals cos x, it's just that would be 180, sorry, excuse me, it'd be 0, 1 or 361 for the maximum turning points. Now there will be an exercise which has got lots of questions like these where some graphs are given. You have to recognise that the sine wave starts here at 0, 0 and works up, whereas the cosine starts high and works down low. So the red curves are all here sine waves. It's given in the question here. Y equals a sine bx, and it's a and b are two numbers, and it's what are these two numbers, what effects does it have in the graph. This is the cosine in blue. Generally y equals a cos bx, where a and b are two numbers. So what you have to get is, on the exercise, you have to fill in these missing positions, how many degrees it is. You have to get the maximum turning point and the minimum turning point coordinates, and you have to write the equation, that is, you have to replace a and b by two numbers. So in this first one, the period is 120 degrees, this is halfway, 60 degrees, and half of that, 30 degrees, is where this peak's occurring. In other words, it's like that. Every quarter, 30, another 30, another 30, another 30. So you have 120 degrees and it's in quarters. So the peak is at 30 degrees 4 and the minimum is at 90 degrees -1. So that's the maximum minimum turning points. You write the x and y coordinates, and this 4 indicates that A has been 4, and the period becoming 120 degrees, that means 360 has been divided by 3, and that gives us B. So there it is. That makes it peak at 4, and that makes the period a third of what it used to be. Now that 3x could be in brackets. Mostly it's not in brackets when it's written, but it would be easier if that was bracketed. You could see that in the brackets you're changing the x coordinates. So that's the first one. Here's the cosine. That's 60 degrees. So halfway is 30 degrees and half of that's 15. That's the key positions there. So 0 degrees 7 or 60 degrees 7 would be the maximum. So the first one's 0 degrees 7. The maximum you would say is 0 degrees 7, and the minimum is 30 degrees -1. Sorry, -7. 30 degrees -7. So that's the minimum, 30 degrees -7. There they are there. The y coordinate's been multiplied by 7, so A here is 7. The period is 60 degrees. You've taken 360 degrees and divided by 6, so that makes B 6. So there's the equation, y equals 7 cos 6x. That's 7 times the y coordinate, divide the x coordinates by 6. Here's the third case. So in this one the period is 40 degrees, halfway is 20, and half of that is 10. That's the quarters there. Peaks at 10 degrees 5, goes to a minimum at 30 degrees -5. There they are there, the maximum and minimum turning points. The y coordinates were multiplied by 5, that's A, and the period normally is 360 degrees. Divide it by 9 and you get 40 degrees. So B is 9. There's the equation. And finally, in this one, where the period's 180 degrees, halfway is 90, and half of that's 45. There they are there, every 45 degrees for these quarters. Peaks at 0 degrees 3, and goes to its minimum at 90 degrees negative 3. So there's a maximum and minimum turning points. The y coordinates were multiplied by 3, so that's A. And the period is 180 degrees, that's 360 degrees divided by 2, so B is 2. You get 2 cycles in 360. So that's the equation. So that's what you have to do in the sheet. The worksheet is on a Google Drive. There's a link in the description. If you click on the link, it takes you to the Google Drive where you'll find the PDF of the exercise. So in the exercise, it shows you a reminder of the basics you have to know about the y equals sine x and y equals cos x curves, general shape. The difference between the sine is it starts low and works up, whereas the cosine starts at the top and works down. You've got the peaks for each. They just happen at different positions. And what you have to do is complete the markings that we just did in the examples on the x-axis, get the coordinates, the maximum and turning points as well, and the equation of the graph. And it will take you through, on this first worksheet, the first 12 questions are all this type. Still to cover the rest of the exercise. So first 12 questions are of this type, and it will have the answers with it. So if you download using the link in the description, you can get the worksheet with the answers, and it's the first 12 questions that you do to practice this. There's also another worksheet there, which is a booklet. So this booklet is on trig graphs, and it's got everything in the booklet you'll be doing and graph transformations, and it's also got equations in it which will come in a later series of videos. So after some examples and all this stuff, the first 18 questions, there's the first one, the first 18 questions are all this type, a mixture of sine and cosine, where it's y equals a sine bx, and you're figuring out what a and b are. So the first 18 questions are all of this type. So that gives it a total of 30 questions, and the booklet has the answers at the back. So that's 2 pieces of work. There is a set of notes that cover all the videos on trig graphs. So okay. So shows you the basics we had so far. We don't manipulate the tangent graph, although we introduced it in the last video. And it will cover more changes than the ones you've just seen. So at the moment you're only just starting the transformations. This is the main type of transformation that come up in questions and in tests and so on. The next video will cover further transformations of graphs, bringing them all together, and there'll be the rest of these worksheets in the booklets will have exercises on these. So that's the end of this video. Hope you found it useful. Thank you.